Hello, welcome to this edition of Momentum. I'm your host, Robert Green, and today I'm fortunate to be joined by Dr. Adam Jones. Adam is an assistant professor in our computer science and engineering department. And today we're going to talk about a lot of things, but one of those is going to be augmented reality and virtual reality. So Adam, welcome. Glad to have you here.
Glad to be here.
So what do you say we take these things off and have sort of a normal conversation for a minute?
Let's do it eye to eye.
Okay, let's do that. Well, I'm really happy to have you here. I guess let's talk about the elephant in the room first. Of course, I was wearing an Apple Vision Pro. You obviously weren't.
Yes.
Tell us what you were wearing.
So one of the things that has been a hobby of mine for a while, and also something I try to incorporate into the work we do in my lab, is we don't just look at the current technology. We try to build the next thing that's going to happen. And this is one of our prototype headsets. This is a prototype from several years back, but me and one of my former graduate students, Zach Garris, built this augmented reality headset out of a bunch of off-the-shelf parts, and that's what I was wearing today.
It's good. Well, it's really nice, and I certainly I've toured your lab many times, as well as computer science, other labs there, and prospective students, man, they got to see what's going on in there. Yeah. So before we get started, let's tell me a little about yourself. Tell me about your education. How did you end up at MSU and end up here as a faculty member?
Okay, so yeah, that's a story. Well, first of all, I want to tell you that I'm a native Mississippian.
Okay.
I was born in Gettysburg, Mississippi. Grew up in Laurel, Mississippi, and my interest in these kind of things started when I was in elementary school.
Okay.
We were part of a program that got a bunch of computers in, and I started tinkering with them and really enjoyed it. And eventually, my folks got a computer at our home, and I decided, about high school that going into computer science, software development, specifically graphics, was what I wanted to do.
Yeah.
And being in Mississippi, the premier engineering school has always been Mississippi State University, and so that's where I went to college. And I got involved in the computer science and engineering program here. And my original goal was to go into software development. And at the time, in order to be nationally competitive, it was a prerequisite, essentially, that you have a master's in computer science. So I decided to go into a master's program here. And I started working with Dr. Ed Swan, who works in augmented reality. And this was the first time I had the opportunity to see what research in computer science was like. Because in other classes, you write a research paper, you research a topic. It's sitting and reading and writing and figuring things out. But for this, research I found in computer science can be getting up and building things, new technologies people have never seen before. And I sort of fell in love with the research side of things at that point.
Yeah. So where in your undergraduate education did you really say, I'm going to go to grad school, I'm going to do the master's and ultimately the PhD? And were there some things you would have done differently had you made that decision earlier?
Well, I knew fairly early that I would probably go into a master's program. Okay. But a PhD wasn't on my radar at the time. Had I known then what I know now about how fun computer science research is, I would have probably planned to go into the PhD earlier. And I'm not sure that would have affected the classes that I would have taken, because those were kind of seminal in getting me where I am, specifically things like computer graphics and psychology classes, actually, because a lot of what we do in VR involves what happens inside your head.
True, yeah. And I think that's a common theme. That's why I like to talk about with faculty is, very few people set out in college, I'm going to get a PhD.
Oh, yeah.
We all come to that via different pathways. So tell me a little bit about the computer science and engineering department.
Okay.
We know we've been having some advisory boards this week, and you are in the largest department in the College of Engineering. Our largest major, of course, is still mechanical.
Oh, yeah.
But with all the majors you have in computer science and engineering, you have the most students. So tell us a little bit about some of the programs you offer there.
Sure. We have a wide range of programs in computer science. I mean, the obvious one to talk about is our degree in computer science. But we also have degrees in software engineering, cybersecurity, AI, and we share a program with electrical engineering that's called computer engineering.
Yeah. Tell us a little bit about AI. I know that's one of the new programs, first in the Southeast.
Yes,
one
yeah,
of the
it's
first in the nation.
Indeed, indeed. It's one of the first in the nation, first in the Southeast, and it's very similar to our computer science degree, but has a very strong emphasis focusing primarily on building artificial intelligence frameworks. And it takes a really fascinating approach. It looks at the programming, it looks at the theoretical constructs, and it also looks at it from the perspective of cognition. So there's a strong psychology and cognitive science component to the degree as well.
Okay. When I talk to prospective students and others, a lot of times they say, well, I like to program. That's why I want to do computer science. But obviously, computer science is much more than programming. Tell us a little bit about that program. What is the job outlook? Is it something a student should consider for a major?
Definitely. So these days, I mean, it's been true to some degree or another that computers are in everything, every field you want to go into. But it's more true today than it ever has been, especially with AI and machine learning making their ways into just about every field. I mean, even on campus, multiple departments that are not computer science have classes that in some way incorporate machine learning and AI, whether to do simulation or generate scenes or imagery. It's finding its way into every field.
Yeah, so it sounds like a lot of opportunities.
There's a lot of opportunities
to do things there. So I mentioned your research lab. You have a very robust research program, and your lab is one of my favorite ones to go into when I'm over there. Tell us a little bit about your research. I know you're doing work in augmented reality, virtual reality. What are those? How are they similar? How are they different? And what are you doing with them?
Okay, so that's a really great question. It's one that I get a lot. So I like to tell people that in the general case, we look at something called extended reality. And this is something that encompasses virtual reality, augmented reality, mixed reality. Honestly, people throw out a bunch of terms that mean approximately the same thing a lot. And the way to really conceptualize it is virtual reality and reality sit on a spectrum, with the real world sitting at one end and a completely synthetic world sitting on the other end. And then everything in between is an extension of reality, so some way that you're augmenting it or mixing it with virtual elements. And so that's sort of the example I like to give of what the difference between augmented reality and virtual reality is. Our specific research in the lab is, I think, really kind of unique and fun. So we look at virtual reality and say, how can we make it better? And we've got methods and tools in computer science and in hardware design and interface design, but it's a very intimate technology. VR docks with your face. Your eyes become the USB boards. So you sort of have to approach it from a slightly different perspective. And one of the things that we do is we incorporate procedures and methods from ophthalmology and neuroscience into studying how the user interacts with VR and finding ways to improve it. But there's also the other side of the coin. The other side of the coin is VR gives us a really interesting tool to study how your brain processes visual information.
Okay, interesting. Yeah, so a little more about that. I mean, we look at this, and of course, we've had VR goggles for a while now. I think most people think of that. They think, oh, it's really cool to play games with those.
Oh, yeah.
So outside of gaming, where do you see the benefit? What is the future you see for VR, just for the average citizen? Maybe not doing research or anything, just everyday life.
Yeah, so I see the benefit of AR and VR in most people's lives almost being transparent to them. A lot of the places, especially in industry, that's going to utilize AR and VR are going to be things that happen to, say, a product or a process before it ever reaches you. For instance, inspecting a vehicle for safety as it's coming off the assembly line. One use case is using AR to highlight areas of interest that you want to inspect on a vehicle before you sign off that, yeah, this vehicle is okay to get off the assembly line. Another good place that we're probably going to see a lot of interest in augmented reality is in medicine. imagine being a physician and being able to effectively peer inside of a patient from data that was collected from, say, a CT or an MRI, and be able to see that information in situ in the patient when doing an examination, and potentially even using it to guide procedures.
Yeah, that would be interesting to do. So I think there are lots of benefits out there yet to see. So you mentioned part of it is, you know, using goggles to see how does the brain process information, visual information. So of course that gets into neuroscience. I know a field of interest you have. Tell us a little bit about neuroscience, maybe what we're doing here at Mississippi State in that area and where you think that's headed.
So in terms of neuroscience, let's start with a basic definition so we kind of know what we're looking at. So with neuroscience, it's really a fairly broad term, and it incorporates a lot of different disciplines. In the basic case, when we say neuroscience, we're talking about procedures and methodologies for studying how the brain and the nervous system function, in the most general case. But if you think about it, it's a really, really complicated topic where we've got aspects of biology, we've got aspects of psychology and cognitive science. We literally have physical mechanisms where physicists study the behavior of neurons, and chemists and biochemists. And also, neurons, on some level, are computational-like devices. And so in computer science, we can simulate those, and we actually use biologically inspired procedures like neural networks, artificial neural networks, to do some kinds of artificial intelligence.
Okay, interesting. Well, we got maybe about a minute or so to go. I know one of the things you do in your lab that you love to talk about is this setup you have, this apparatus to train persons with disabilities on how to drive vehicles. And of course, that training is required for them to be able to get a license to drive that. Tell us a little bit about that. What is it and why is it important?
Well, this is a project that I think is really special. It's something that we work on with the T.K. Martin Center here on campus and CABS and the College of Education. And basically, it's a way to enable people who, say, have a physical disability and have to use a modified vehicle to train for using that modified vehicle in the comfort of their home before going up for their certification. Because if you think about it, you're already at a disadvantage getting to and from places not being able to operate a vehicle. And there's very few places in the state that do the training and certification. Mississippi is still a big state, so it's likely that you probably don't live near one of those places. So we thought, is there a way that we can use virtual reality and something that's local to everyone, say a Walmart or a Target or something like that, where you can get off-the-shelf components and then install our training software on it and do the training in the comfort of your home before making the trip up to your in-person training.
Yeah, well, that sounds like it's going to be a huge asset to the people who need it. It sounds like you've got some really good research.
Thank you.
I certainly encourage any student, anybody else who's interested as well to come and see what all you have going on in your lab as well as in the computer science and engineering department. I want to thank you all for joining us on this edition of Momentum. Look forward to talking to you next month with a new guest. So have a good weekend and see you all next time.